హాయ్ ఫ్రెండ్స్, వెల్కమ్ టు ఎస్వి టెక్నాలజీ. ఈ వీడియోలో మనం లాజిక్ మైక్రో ఆపరేషన్స్ గురించి చూద్దాము. లాస్ట్ వీడియోలో మనం అర్థమెటిక్ మైక్రో ఆపరేషన్స్ గురించి అండ్ మైక్రో ఆపరేషన్స్ అంటే ఏంటి అవన్నీ కూడా చూసాము. సో అందులో సెకండ్ టైప్ లాజిక్ మైక్రో ఆపరేషన్స్ గురించి ఈ రోజు చూద్దాము. మీరు కనుక ఈ ఛానల్ ని ఫస్ట్ టైం విజిట్ చేస్తున్నట్లయితే ప్లీజ్ డూ సబ్స్క్రైబ్ అండ్ లైక్ ద వీడియో. ఓకే, లాజిక్ మైక్రో ఆపరేషన్స్. Logic micro operations specify binary operations for string of bits stored in register. So arithmetic operations are performed on numerical data which is stored in registers. But logic micro operations numeric data మీద కాకుండా string of bits మీద అంటే collection of bits మీద work అవుతుంది. These operations consider each bit of register separately and treat them as binary variable. Means ఆ రిజిస్టర్ లో ఉన్న ప్రతి ఒక్క బిట్ ని ఒక వేరియబుల్ గా కన్సిడర్ చేస్తుంది. సో ఫర్ ఎగ్జాంపుల్ లాజిక్ మైక్రో ఆపరేషన్స్ కి ఎగ్జాంపుల్ ఏంటంటే అండ్ ఆపరేషన్, ఆర్ ఆపరేషన్, ఎక్స్ఆర్ ఆపరేషన్, ఇవన్నీ కూడా లాజిక్ మైక్రో ఆపరేషన్స్ కిందికి వస్తాయన్నమాట. నెక్స్ట్ వచ్చేసి ఇక్కడ నేను కొన్ని లిస్ట్ ఆఫ్ లాజికల్ మైక్రో ఆపరేషన్స్ ఇచ్చాను, మీరు చూడవచ్చు. సో ఇక్కడ ఎఫ్ అనేది ఒక బులియన్ ఫంక్షన్ అనుకుంటే లాజికల్ మైక్రో ఆపరేషన్ లో ఎఫ్ ఈజ్ ఏ బులియన్ ఫంక్షన్. ఇక్కడ 0 to f అని రాసాము. ఓకే, అంటే వీఆర్ పాసింగ్ ద వాల్యూ 0 to f బులియన్ ఫంక్షన్. మీన్స్ ఐఎమ్ సేయింగ్ దట్ క్లియర్ దట్ రిజిస్టర్ వాట్ ఎవర్ ద కంటెంట్ ఇట్ మే హ్యావ్. అంటే అది ఏ కంటెంట్ ఉన్నా సరే, సపోజ్ ఆ రిజిస్టర్ లో 1 0 1 0 అనే కంటెంట్ ఉంది, అయినా సరే అది ఏమైపోవాలి అంటే ఆల్ జీరోస్ అయిపోవాలి. ఐఎమ్ సేయింగ్ దట్ క్లియర్ దట్ కంటెంట్ వాట్ ఎవర్ ఇట్ ఈస్ ఇన్ ద రిజిస్టర్. ఓకే, బై యూజింగ్ ఎఫ్ టు 0, ఐ మీన్ 0 to f అనే ఫంక్షన్ రిప్లేస్మెంట్ అని చెప్పుకున్నాం కదా. ఎఫ్ విల్ బి రిప్లేస్డ్ బై 0. వాట్ ఎవర్ ద కంటెంట్ ఎఫ్ హ్యావింగ్ we don't know, that will become 0 if I pass clear operation. Next వచ్చేసి A and B. So you know that what is AND operation and you know that what is AND symbol. So this is the symbol of AND. So A and B means the operation is A into B. The multiplication operation in COE is performed by AND logic. AND logic performs multiplication operation. So if I say A and B means I have to perform the bits of A with multiplication with bits of B. Next, exclusive OR operation or exclusive NOR operation will be there. So it will be represented by A and this is the exclusive OR symbol. Okay. Next, bar. So B bar means complement. Complement means ones will become zeros and zeros will become one. Suppose I have a number like this 1 0 1 0, that will become after the complement that will become 0 1 0 1. Means all the numbers are inverted, means changed. Zeros will change it to 1 and ones will change it to 0. Okay. Next, NAND operation. So NAND operation means it is opposite of, I mean complement of AND operation. So you have to do AND operation, then you have to do one's complement on that AND operation, then it will become NAND operation. So next operation is OR operation. OR operation means the addition operation. The addition operation in COA will be represented with OR operation. So NOR operation. What is mean by NOR operation? The operation OR will be complemented. After doing OR operation A plus B, then you have to do complement on that A plus B. Next, exclusive OR. Already we have discussed about exclusive OR. What is mean by exclusive OR? A plus, suppose we have two register A plus B, then B bar plus 1. Okay. A plus B bar plus 1 is called as exclusive OR operation. Means the second number's 2's complement will be added with the first number and F will be replaced with 1. This is a pure opposite of first operation, which is clear. In the clear, whatever the operation we have, whatever the content we have in that register will be replaced with zeros. In this, F1 to F means the Boolean function F will receive 1 and whatever the content in register will be replaced with all ones. Okay. Next, another Boolean operation or another logical operation is A bar and B. So what we have to do here? We have to do the complement of A and multiply with B. Okay, we have to do complement of A and multiply with B. And we have to do complement A and add with B. Okay, so like this we have all the Boolean operations. Here I have mentioned a few Boolean operations like this. So 0 all clear, x into y and x y dash, x dash y dash means bar here, x y exclusive or exclusive nor, okay, or nor, okay, like this Boolean functions we have. So here we will discuss some block diagram and everything about these Boolean functions. So here we will discuss about hardware implementation of this logical micro operation. The hardware implementation of logic micro operations need logic gates. To perform logic micro operation, obviously we need logic gates. Okay. There are 16 logic micro operations are there. In above list I have shown total 16 micro operations. To perform that all 16 micro operations, we need only 4 logic gates called AND, OR, NOT and XOR. Okay. So suppose we need NAND. What we have to do? AND plus NOT. Suppose we need NOR. What we have to do? OR plus NOT. Suppose we need XNOR. What we have to do? XOR plus NOT. Like this, with the combination of these 4 logic gates, we can perform all 16 logic micro operations. Below block diagram shows the one stage of circuit that generates 4 basic logic micro operations. So by showing these logic micro operations, 4 gates we are using. So by these 4 gates we can perform all 16 micro operations. So here I am taking a register A and the second register is B and the bits in register will be AI. Okay, suppose it is 4-bit register, AI will be A0, A1, A2, A3 like this, and B register will be B0, B1, B2, B3 like this, and I have 2 control signals S0, S1. So to select these logic gates, I will use these control signals. So how many control signals I have? 2 control signals I have, means total I have 4 possibilities. Okay, 2 control signals may have 0, 0 or 0, 1 or 1, 0 or both are 1. This is S0 and this is S1. I have 2 control signals, means I can have 4 possibilities. So if it is both are zeros and the control signal 1 is 0 and the control signal is 2 is 0, then I have to perform AND operation. If control signal S0 is 0 and control signal S1 is 1, I have to perform OR operation. And control signal S0 is 1 and control signal S1 is 0, I have to perform XOR operation. And control signal is S0 is 1 and S1 is 1, both are 1, I have to perform complement operation. Like this, using these control signals, I am going to select the operation from these logic gates. I am going to select the logic gates. And I have connected this with 4x1 multiplexer. What is the nature of multiplexer? We have seen in last classes. It takes n number of inputs and gives single output. So it takes n number of inputs and it decides one output should be there. Okay. So this is called function table. This is called logic diagram. Okay. I will explain this again in theory also. Don't worry about that. So here I have explained whatever we have discussed earlier. The above block diagram consists of 4 logic gates and 1 multiplexer, 4 by 1 multiplexer, that is to the output of the gates are applied to input of multiplexers. 4 inputs will be there for each logic gate, 1 input will be there and that will be connected to multiplexer. The 2 inputs are A and B, 2 selection inputs are S0 and S1. Total 4 inputs will be there. Choose one of the inputs from logic gates. So to choose one of the inputs from logic gates, we are using S0 and S1. If S0 S1 both are zeros means I will choose the AND gate. If S0 and S1 both are ones means I will choose complement, NOT gate. And if this S0 is 1 and S1 is 0, I will choose XOR gate. Okay. If S0 is 0 and S1 is 1, then I will choose OR gate. Like this, I will select the logic gates out of 4. I will select one logic gate, and by using these 4 logic gates, I can perform all 16 logical micro operations in COA. Okay.